would the suicidal function say? Goodbye world? How do you measure size of a function? In parameters? Not parameters? Can we start?
Yeah.
All right. So let's talk about Testacular and how Testacular makes AngularJS super heroic. So for those of you who don't know, I'm Mishko Hebri. I work on AngularJS. AngularJS was my baby. I've been working on it now for about 3 or 4 years. It's a framework for building web apps. How many of you guys build web apps? Most of you guys, awesome. And have you used AngularJS? Okay, 1, 2, 3. Do you love it? No? Are we going to change your opinion on that? Okay. So specifically what I want to talk about is the testing environment. It turns out that the way you set up your machine very much determines how you're going to test everything. And so we're going to talk about environment. The whole trick of it is to remove all possible friction to testing. You want to make testing so easy that it's the easiest thing to do. It's the lazy thing to do. It's just easier than everything else. And that's what the whole talk is about. And it turns out that it's not so simple to do this, or rather, there's a lot of know-how that you have to have in order to make an environment that is low friction for testing. But it's not sufficient to have a low friction for testing, because it really separates out into a lot of different pieces. So you have unit tests and you have end-to-end tests, and you have to have a good story for both of them. But it's not just having an easy development workflow, it's also about having easy debugging workflow. And furthermore, it's also about having good continuous integration workflow. And so there's different things that are important for all those pieces. So for development workflow, the only thing that really matters is speed and flow. Flow meaning that it's just easy to do it. I don't have to fight the system. For debugging, well, having a debugger is a big deal, so we don't have to do printf statements everywhere in order to debug our stuff. And finally, for continuous integration, what's important is to have autonomous, meaning that it runs by itself, I don't have to interact with the system. And it turns out that the way browser is designed, it makes all of these things miserably difficult. And the reason why it's difficult is because there's a sandbox, right? And the browsers do all these things to prevent malicious code from doing anything bad to your system. But it also means that browsers cannot tell you whether something has passed or failed, especially if it's difficult to do this in an autonomous way, like in a build system. And so to answer this set of questions, we built this tool called Testacular. And Testacular is, it's, by the way, for those of you who are wondering what it stands for, it's testing done spectacular, Testacular. And we address all this. So I want you to keep this in the back of your head while we talk about all the other pieces. Finally, it turns out the kind of libraries you choose will dictate your environment. So, and this is kind of a call to action. For those of you who write libraries or frameworks, you know, for the longest time we've been in this world where people write frameworks and they kind of throw it over the fence and make it public and they say, here, use my library. But none of these frameworks or systems basically tell you, well, how do I test with this thing? In other words, you are left to your own devices to come up with an environment that's testable. And so when I built AngularJS, I wanted to make sure that it's not just about giving you a useful set of tools, but also part of the philosophy it has to be, testability is built in. So I wanted to make sure that the framework not only helps you build your stuff, but the framework also will help you to make your application naturally testable. And so this is something that I don't see from other libraries. So if you decide to use jQuery or any other frameworks, usually they don't come with a set of instructions about how to structure your code and how to run your code and so on. And so this is where I think Angular is unique, is that not only does it help you write the apps, but it also says this is how you test it. And AngularJS does a couple of things. It has dependency injection built in. If you're on a server side, dependency injection is old news. If you're on a browser, it turns out dependency injection is new news. As a matter of fact, most people haven't even heard of it in the browser world, which is kind of strange. The second thing we do is we give you mocks out of the box. So all this stuff like talking to the server, URLs, cookies, we have mocks that is available for you inside of your unit test when you're building an AngularJS application. And this is so there's two parts, right? There is us being able to test our own framework, and then there is you being able to test your application that you're building. And we want to make sure that you have easy time. And finally, we spent a lot of time making sure that the DOM is separated from the controller so the controllers can be easily instantiated. So all this stuff is is macro level things we do so that when you write your application, it's easy for you to test it. So, I am going to tell you a little bit about Angular before we do a whole bunch of demo. This is going to be super quick because the talk is not about Angular. Yes. Yes. The internet is slow. Load faster. Okay, forget it. No. Okay, so quick history of browsers. Browsers look like this. I just click through it. This is how they look today. It's like they look nicer, right? But that's not important. What's important is all kinds of different crazy apps we can do in browsers today. And most of these apps are applications in the classical sense. They're not static documents. Like, you can play games, you can check your email, you can develop an IDE. This is pretty crazy. You can actually build apps in your web browser, right? It's kind of recursive. And as a user, I'm pretty happy, but as a developer, I'm not very happy because it's super complicated to build web apps. And the reason why this is because apps are static, documents are static, and that's really super easy. You can kind of explain this to your grandmother, and she understands what Hello World will do, right? Whereas that's Hello World in JavaScript. This is insane. Like, this is the craziest Hello World if there is such a thing. And all of these bits and pieces actually make sense. And so what we wanted to do is we wanted to say, well, how do we simplify this, right? And so there's libraries such as jQuery that make it simplify this particular thing, but they make it in an imperative way, meaning that you have to execute the code in order to know what happens to it. And what jQuery does is it makes the APIs more sane, but if you think about it, jQuery shouldn't exist if the browser vendors had sane API to begin with, right? And the jQuery doesn't in any way change the abstraction level, so you still have to know about the events and what will happen, how to get it done, and all the other stuff. And so what we wanted to do is declarative, like you see over here. Just like you have a hello world static, we wanted to be able to do it dynamically as well. And so you can do data binding. I'm going to skip over that. And I'll skip over that. So the important thing is, just like in code, you can have functions because you need something over and over and over again. You can have, in HTML, if you want to create a set of tabs, you have to create all this complicated set of URLs and divs, etc. And it's not really telling the browser what you're doing. You're kind of indirectly telling the browser, right? And so this stuff on the right-hand side is much nicer than the thing on the left-hand side. And this is what Angular allows you to do. But really, we're going to talk about testing, so I'm going to skip all this stuff. So let's talk about testing. So here's an example of an application. And by the way, let's make this interactive. Keep asking questions. Don't make me do just all the talking here. So this is an example of an application. Let's see. One of the things I can do is find restaurants. The idea is you want to be able to get a list of restaurants. Actually, let me show you a working app. So you have a list of restaurants over here. You can filter a set of restaurants. You can go to a specific restaurant. You can add things into your checkout. And you can check out, put your credit card information in there, change quantities, let's say. And you can just, whoops. Oh, I can't purchase because I don't have payment. Like that. Okay, so let's say you wanted to build this app, and more importantly, let's say you want to test this app, right? So let's go back in time before we actually built all this stuff. Okay. specifically, let's write a scenario test. So in this particular case, let's go to home. Okay, so this is supposed to add for the name. So let's say I want to say my name and Kiev, and all it does right now is just alerts it. So if we go to code, and we go to, oops, customer controller, this is basically what the controller does. As you can see, it's nothing exciting over here. It just says, when you get things from the server, do an alert. The other thing you probably need to know is here is our form. Here's our form. Here are the inputs. You can see that we have bounded to customer name, customer address, and then when you click it, you call the find restaurants function. Now, there's two kinds of tests you can write. You can write a scenario test and you can write a unit test. So in this particular case, the unit test is rather trivial, right? We can just instantiate customer controller, pass in an empty object, and then which is the scope, and call the find restaurants method, and then assert that it calls alert. Except for the fact that alert is a global method and does horrible things that makes this particularly difficult. We'll address that later. But we can also write an end-to-end test. And an end-to-end test would look like this. Now this is when we're actually pretending to be a user and we're actually clicking on it. So literally, we're saying navigate to this URL, which would be this one over here. We're saying go and enter particular things inside of the form. We have to do a little bit of mocking to override the alert. We can click the button and we can expect that the right things happen. Now, how does Angular help with all this, and how does Testacular help? So first of all, this kind of looks like Jasmine, and this is intentional. It's actually not Jasmine. One of the first things that's interesting about here is that we made a test runner that understands how the application works. So when you execute something like this, you can't just go and execute the next step, because browsers take some time to go and navigate to this URL. And so what really you need to put up there is some timeout. The question becomes, well, how long do you have to wait? And that's a very vague question. So it actually turns out that what we have built is we have built a test runner that actually communicates with the framework. So the two of them exchange information. And the test runner basically says, you go over there to index.html, and you tell me when you're done so that I can do the next step. And what that means is that our test looks synchronous, even though in reality they're very much asynchronous. So one is the syntax of it. The other thing is, how do we actually run this? So for this, we have Testacular. It has this configuration file. We'll go through over all these things, but let's run it. So, first of all, I have to show you where the tests are. Here's the tests, which basically the first test is enter the stuff and alert and prove that alert happened. And the second one is that if I haven't filled anything out, the button should be disabled. And so what's happening over here is it allows us to, when we execute it, it actually says that the first test has passed, and the second one has failed, and you can see the button has failed. Now notice a couple of things about the friction, right? Keep in mind that I'm talking about the friction of how it is to test. I can just click run the test, and it executes this. Now this is a scenario test, so it's not, if you look at it, 1, 2, 3, 4. So it's about 4 seconds to run this thing. So that's a little slow for what we would like, but this is kind of what you have to deal with when you have end-to-end tests. This is why unit tests are better, because you can run more of them. But nevertheless, notice the first difference, which is that I never leave my IDE. I can just simply live inside of here. So more importantly, I can put a it. Okay, why is my keyboard not working? It works. Seriously? That happens from time to time.
ask a question?
Sure, yes.
So do I understand correctly that you have something on the framework side that helps with this kind of end-to-end testing? So it's really specific to Angular, right?
Correct. That's correct, yes. That gets a t-shirt. And a set of stickers and things.
M please.
Yeah, please. Yeah, make sure you ask before the M's run out. Alright, let's try this again. Right? And here's our scenario. And two of them failed. We can, for example, by putting it, we can run just that one test. So now you'll see that one is skipped and that one's still failing. So notice what we're trying to do is we're trying to make it easy for you to run the tests. Now, when we have a debug statement like this, the way to fix this, I believe, is to say, and you got the save. Is that what it is? One has a name. And it's required this. So we disable it when my form is invalid. Let's see. The button is disabled. When I put in my name and Kiev, notice the button becomes enabled, right? Delete Kiev is disabled. So that's something that framework does. Notice how easy it was to add this particular behavior. And that should make it so if I run my test, I should be able to pass. Great, so I passed my test. So let's do a couple of other things.
What is name invalid? What is that magic?
What is this magic?
Yeah.
This is Angular's magic. And I would love to tell you about all the Angular stuff, but unfortunately, we're talking about testing, not Angular. But check it out. Angular has amazing things that can do form validation, do just a few things. Where was I? Oh yeah. So notice I said there's this running, there's this debugging, and there's this continuous integration. So what we're doing right now is actually the continuous integration scenario, because notice when I run, I'm going to quickly. No, you're not going to show me. Hold on, let's make it the thing, right? Okay, here's the second test. Oh, it's too quick. So basically, it launches the browser, verifies the test, and shuts it down. This is the continuous integration mode. So what we would like to do is have a development mode. And so development mode basically says, instead of constantly starting the browser and shutting it down, can we just keep the browser running? So by just reconfiguring Testacular, we're basically telling Testacular, okay, start the browser once, don't shut it down. So notice, if I launch this, there's a browser that gets launched, and it stays open. And it remains captured. And I can show you that if I now try to run the tests, 1, 2, okay, that was way quicker. Did you see that? So about 1 second now to run our end-to-end scenario test. And the reason why it's so much faster is because the browser don't have to be shut down and started up. So that makes the testing environment better. Now, if we're so quick, we could actually run this on each save. But let's talk about debugging now. So sooner or later, you're going to get into a situation where you need to debug. So there's a couple of reasons to debug, a couple of ways. First of all, the reason why Testacular can be so fast is it basically is very aggressive about caching the files. It basically tells the browsers, these files will never change. But of course, we need to have a way of busting the cache in case the files do change. So what happens is the URL contains a SHA. You know what a SHA is? It's a checksum of the file, that provided that the file doesn't change, the SHA stays the same. So the browsers will cache specific images of these particular files, and then they don't have to do it faster. It turns out modern browsers do all kinds of tricks. They not only cache the files, but they also cache the AST. So even if you have lots and lots of files, it executes very quickly. But that prevents you from doing debugging. Because if you put a breakpoint somewhere, so if we're in here, sorry, let's get this thing going. So it's localhost 1977. Notice we actually executed our 2 tests, and now we're not doing it from ID, we're actually debugging it. We can go into the source and look at it. When you're putting a breakpoint on a specific line, that line contains a SHA, which means if you change the file, all of a sudden the breakpoint is now in the wrong file. So we have two basically modes. One mode is where we're super fast, but you can't debug. And we have another mode, which is this one over here, where we are a little slower, but you get to debug because we can put breakpoints, and these breakpoints are persistent. So we kind of think about all of these pieces. Does that make sense? Am I kind of? Okay. So now the next thing is, well, we would like to debug. So it turns out there's a lot of different ways you can debug. So let's go back and let's get a debugger running in this window. And let's go put it, you can, one way of debugging is actually, I don't know if you knew that, you can actually say debugger in your code, and then you can run your test, and notice it actually stopped automatically on this particular line, and you can examine the status of your thing. So in this case, you can see what it is right there. We can actually mess with this, right? You can say, let's see, customer name is equal to, yes? Yes, this is something that JavaScript has built in. This is not something that I invented. Let's see, we put an X in here, right? And we run this. We're running too fast and close the window. Okay, you guys are not cooperating. Okay, let's try this over here. Notice, because we were in the other runner, it prevented us from doing that stuff. So let's try this again here. Customer name, show customer address. I'm gonna break this and run it. And you should have failed. Why didn't you fail? Oh. Okay, I'm confused a little bit, but it should have failed. I'm not sure what's going on, and I don't want to spend time debugging it. The point is, you have a debugger, but this is not the best way to write a debugger. A better way to do debugging would be actually to put a breakpoint right here. Now, that would be cool if we could do that, right? Let's see if we can. Voila. So this is actually now we're debugging inside of our IDE, and we're debugging a real browser. So I believe this is the window that's being debugged. And as you can see, this is the stack trace. We can look at fields. We can look at the stack, how we got here. We can change values by doing this. No. Okay. Edit, right? Oh no, that's the edit this thing. I'm sorry?
It's a trial version.
It's a trial version of WebStorm? I don't know. I think I paid good money for this. I don't know what's going on in there, but it should allow you to edit these things. Maybe because, I don't know.
Because of demo.
It's because of demo? Yes, that's what it is. The demo demons are not with me today. But anyways, so I wanted to basically show you that, you know, when you get a library, a third-party library that you use in a project, the library authors don't usually think about how you're actually going to debug this stuff and how you're going to write tests and unit tests. And so I just wanted to demonstrate to you that I think the world is changing. The world of yesterday was the case where people just gave you libraries. And I think the world of tomorrow is going to be the world where not only do people give you libraries, but they also give you testing stories as to this is how you integrate all the pieces, this is how they will work, this is the mocks we want you to use. And it doesn't mean that you have to use our stuff, but it means that absence of you scratching your head and trying to figure out what's something better, you have some initial stage you can use, right? So let's see if we can do unit testing. So this is end-to-end tests. And I think if we fast forward, just do this. By the way, this code is all on GitHub, so you can check this out as well. So just like we have Testacular. Okay, this is the end-to-end runner. This is over there. Okay. So we configure the master. So let's see. Let's run our unit test. So let's run Testacular. This is going to launch. Actually, let's close this. Let's try it from the beginning. Okay. So that launches the browser and captures it. Now I'm going to show you something cool. How many of you guys have computers over here running? I have config. So looks like my IP address is 192.168.1.24. You see it? Okay. Safari. So go to that URL 192.168.1.24.9876. Not everybody, but a few of you. You can even take your phones out or tablets.
Yes.
You got it captured? Okay, we have one guy captured. Okay, yeah, perfect. See, notice it says over here who's captured. So we have people that are coming online. Look at that. So now I'm going to use your machines to run my tests. Ready? And this test intentionally failed, but notice I have a Safari failure, another Safari, another Chrome, another Chrome. Looks like some people have slow machines, they're still reporting back. The point I'm trying to demonstrate is that oftentimes you have to run your unit tests on machines other than which developing. I develop on Mac, but maybe you have to actually run it on your mobile device or your or IE. I'm sorry if you have to work with IE. So we wanted to make sure that, here we go, more devices, these are tablets reporting back or phones. More devices are coming in. So could I get you all to close it, because that's going to make the demo super slow. Of course.
So basically, during testing, we can have a few devices, say a few mobile devices with several browsers.
Yes.
And have testing results for JavaScript for our pages in real time for 5, 10.
Exactly. I still see that there's a whole bunch of people connected. Could I get you to get off, please? Okay. One more person. Somebody is still connected, because I should be the only one running. Okay, you keep leaving and coming back. Thank you. No? Okay. I'm going to change the port if you keep coming here. All right, let's change the port, because... You just close your window, right? You just close. Whoever is still open. IE. The guy needs a t-shirt. Who's the IE? Get a t-shirt. There's also some stickers over here. But I'm serious. Get off this thing so that I can do the rest of my demo.
Please.
So here's our stuff. So let's see the spec. Here we go. So here's our spec. And let's close this for a second. So let's look at it. So we're saying we're going to describe the services for a customer, and before each we're going to do something. This is Jasmine, so you should be all familiar with this. But there's a couple of unique things in there. So for example, we actually brought dependency injection into JavaScript and into the tests. So in your application, you're going to have to get rid of get hold of the customer and the root scope. And notice, instead of calling new operators on this and getting the dependencies in there, etc., you can literally just ask for them using this magical inject method. You say, hey, I really want to get hold of the customer and root scope. What we do is we look at the parameters of the function, because unfortunately JavaScript doesn't have annotation. but we can look, we can retrospect on a function and figure out what the parameter names were, and we can assume that the parameter names are actually the service names. And then we know that you want to have customer and new scope. Now, if you look at the customer, you notice that it has a reference to scope. That's why inside of our spec, we also get a hold of the root scope, so we could go modify it as well. And let's see, what kind of test do we do here? We say, oh yeah, one of the things we do is, let's go back. So there's a customer, local storage, customer controller. All right, this is the, okay, so let me back up a second. This is broken tests. Let me go to actual implementation of the tests. No implementation here. Okay, bad example. B. Ah, that's better. So here's this customer service. What is the customer service? Let's have a look. Customer. Notice it's a object that talks to the browser's local storage, and this is basically where our application now becomes I/O bound. So what we really would like to do in the test is say, instead of using the real local storage, go use a fake one, right? And the way we do this inside of our test is, notice we simply say, hey, there's this new module. Module is the way you configure the injector. And we basically are saying, you know, if somebody asks for local storage, instead of giving them the real thing, give them this fake one right here. So that inside of our test, notice we can say things like, we can write name and address, and then we can say, hey, the local storage should contain this JSON object. And we can do this without actually incurring the cost of talking to this. And we also know local storage is persistent between different tests, so we don't have to reset between different tests because it automatically gets reset for us, because this injection happens before each unit test, right? Now, let's run these tests. So first so we're still running the stack that we are. Now, let's run them. Okay, so some people are still on. This, restart. No. Some people are still on. You're making my life difficult in terms of testing. Let's see. Yeah, it's slow because it's making more than I want. Okay, so let me do this for 15 minutes, okay? I'm going to do this. I'll change the port so that I'm the only one here. All right, I'm the only one there. No, somebody changed their port. You are just not going to make my life easy, people, are you? See, it's not fast if you connect over the network. But anyways, the stuff is coming from different machines. And this is my test. What I wanted to show you is that when I'm in the controller, the way I like to write tests is literally if I just change the file and I save it, notice that the file, it automatically triggers running of the tests. So let me try this again. Clear, save. Is it disabled? Auto watch true. It should be running it automatically, unless the previous test did not finish. Anyways, the point is that you can set up your IDE that it simply does it on every save. And So for example, in this case, we can have a stack trace and we're saying that the issue seems to be over here, that we expected /customer URL. Oh, that's because we don't have redirection going. So that should be relatively easy to implement. You can just ask for location because it's dependency injected. And then after we, oops, that's the wrong place to ask for it. It's customer controller. Ask for it, and we implement it. Dot. So, yeah, it's still waiting for previous execution. So whoever's still connected, you guys are not helping. We're kind of coming to an end, but I wanted to turn this more into a discussion and kind of give you an idea of how testing is done. So for example, in Angular we have 1600 unit tests, and we can execute all 1600 of them on every save, and they execute in about 3 seconds on a browser. So that basically means that the whole framework can get tested every time I change any line. Questions? Who watches the changes? So that's a good question. So you can set up your Testacular configuration file, and it does auto watch. The way it works is that the Testacular is a server. It's a Node.js server. It starts up, it watches the file system, and then the browsers connect to it through socket.io. And then the server then pushes information into the browsers and also collects test failures from the browsers and either puts it into standard I/O, or a separate process, which is the Testacular run, can connect to the server, cause it to trigger, and then it can get back the reports. That's why in this tab, the server is continuously running. And in this tab, I can simply cause a run by clicking it on once, and then I can click on it again, right? So the idea is that once you start up your server and you capture the browsers, you don't want to be constantly recapturing them. You just want to keep them there. And you just want to have a process which can execute and then tell it to quickly run and can push new stuff and can report back results.
Can you set up manage each file or each change?
Currently, it's just on anything. So any file that changes triggers it. If you wanted to, you can disable this automatic watching, in which case you have to manually execute it using the Testacular-1 option, which is shown over here, and then you get to decide when to run it. Okay, if you want to run a subset, what you can do is, you can, for example, put a ddescribe here, and this is only going to execute these tests, not the whole test suite. You can also put an init. In this case, only this particular test is going to be executed. So, somebody else? Questions? Shirts? Can you make sure the shirt make a shirt? Yes?
Maybe there's some kind of interception of requests, or not requests, and blocking responses from the server.
Oh yeah. Very good point. So, let's go to, let's see, step 20. So, actually, it's very nice. I'm just not remembering where exactly I have an example of this, but you have this thing called a mock. I don't think I have an example here. But you get a hold of this thing called HTTP backend. Let's do it this way. And there is basically methods in here. Here's an example where you put when I get a get on a particular URL, respond with this, and then inside of your test, you can pretend that the response comes back from the server by flushing it. That's what causes the response to come back, so you can have asynchronous situations. And this is something that's already built in the framework. Yes?
Is there any way to use Testacular outside of AngularJS code?
Absolutely. Testacular is completely independent from Angular. It is something we use internally. And it's independent from Jasmine, so you don't even have to use Jasmine with us. Just Testacular is a way of capturing the browser and telling and loading script tags into the browser and then executing your tests. It has nothing to say about what format your tests are written, whether you choose to use Jasmine or Mockito or anything like that, or even QUnit or YUI. It simply says, I will load the stuff for you and I will let you publish information back out. But everything else is up to you. It's really a different beast. Backbone is a way of watching model changes on a model, and it's very explicit. You have to inherit from a model, and you have to have special getter and setter API for modifying the model and interacting with the model. Angular does so much more. Model is observation is a small portion of it. We can also do. We have services. We have dependency injection. We have form validation. We have you know, it's just a way more encompassing framework rather than what model. I mean, Backbone is like 4 kilobytes. It's just. That's one way to look at it, but it really, in a way, it's the wrong question because the two are not apples and apples. You know, it's like saying, what's better, bicycle or a car? Like, well, car's faster, but that's not why it's better than a bicycle or vice versa, right? Like, it's a different thing. Yes?
Do you have any statistics about rising of number of lines using Angular as an application?
I do. So the reason Angular got written is because I was actually working on a GUID application at Google, and I was being frustrated by the progress I was making with the GUID application. And so I said, you know, I could get these ideas of dependency injection and data binding all into it. And so we went from an application written in GUID, which was 17,000 lines of Java code, into Angular, and it became 1,000 lines of JavaScript code. So 17 to 1, it's a big difference. And since then, other people have rewrote their applications as well, and they got similar numbers. They got about 15 to 1 or something like that. We always see at least 10 to 1 when people rewrite it. So it's a huge improvement, but you know, AngularJS is not a generic framework. It's not good for everything. I wouldn't write games inside of it. It's mainly good when you have CRUD-based application, which fortunately is like 80% of the web. But it's outside of the CRUD, you know, I wouldn't use it for, as I said, a game or a word processor or something like that. Yes. It's free. It's the best price ever. Can you see what? Sorry. So here's our continuous integration server. It's a little slow here. We don't have internet?
We have Wi-Fi,
but no internet. Okay. Basically, we report our stuff in JUnit style. So most continuous integration things, they already know how to consume JUnit XML format. So it just kind of works with things like CI. The actual running of the end-to-end test, we'd have to set it up. You kind of saw that at the beginning when I showed you the pages when we went through individual steps. That's kind of what it runs. But we don't have a report per se other than whether it failed or passed, and then it's turned into an XML format, which is essentially JUnit, so that your continuous integration can report proper information. But that's all we have. Other questions? Yes?
So I wonder, what is the border between the
Where's the border?
I mean, how much of that what you show is Testacular and how much is Angular? In the sense that, for example,
Yes,
there
So,
are those mock objects.
Yes, so mock objects is something Angular provides. The environment is something we recommend, so I guess you could give that to Angular as well. The Testacular, what it does is the server that you can connect to, and as you saw, anybody can connect to it. And it's a way of pushing script tags into the browser without actually writing the HTML file, and then reporting back. So what Testacular knows is how to launch browsers, how to run it in two different modes, which is the debug mode, which is slower, but you can debug, and then there's faster mode, which the debugging doesn't, it's kind of broken in there. It knows how to integrate with continuous integration servers like Jenkins, which you see over here, which can then put out the reports into JUnit format, so you can see. So let's see, we can kind of zoom into one of these. So this is the kind of reports you can get. But that's kind of the idea, right? The Testacular's job is to run the scripts. Last question, because we're out of time. Yes.
Angular provides all these mocking objects and all these enhancements to make your test writing easier. And before that, jQuery came out with the QUnit, right? And I would imagine that at some point later, I will have several frameworks which will all think about the testing and provide their own infrastructure and enhancements of all that stuff. And they will step on each other. It's something that I currently have problems on the clients like AngularJS. When I have several libraries that do the same things differently. And
so are you talking about the testing framework stepping on each other,
yeah,
or the libraries stepping on each other?
The libraries stepping on each other in testing code too.
So whether the libraries step on each other or not is a question of how much global state they have, right? And so Angular was actually written with jQuery in mind, so it uses jQuery when it's available, and when it's not, it has its own kind of bare bones implementation of jQuery just to get by. It is also designed to have no global state, so that it should work with all other frameworks. So it's a question of the developer of the library, whether he thinks about others, and whether he plays nicely with others as well. So it's not, there's no global answer that's true for everybody. Anyways, we're out of time. Thank you very much.